Namaste everybody. Before beginning, YouTube has told me only 20% of you have pressed the subscribe button. Please just press the subscribe button. Just press it. It'll help us reach a wider audience and help us create more content like this. So welcome to the 11th video of our series Becoming a LEED GA. And in this video we'll be talking about water efficiency, the strategies and the intents. And this video is part of a social initiative where we are trying to train maximum professionals to build more responsibly and to help mitigate climate change. So just sit back, relax, and understand the concepts first before trying to write down things, because when you understand concepts, you'll understand more broad things about the complete concepts, and that will really help you in your future. So let's begin. Okay. Uh, Let's try and understand the basics of water conservation. All the concepts of water conservation revolve around the use of potable water. Potable water is water that meets the minimum requirement for drinking, cooking, and domestic use. You use potable water not just for drinking, but also for irrigation, hand wash, and even for flushing. But we need to understand that the huge amount of infrastructure goes into treating the water so it becomes safe to drink. Just think about it. The water you have in front of you for drinking was sourced from a water body, either from river, lake, or groundwater, then sent to water treatment plant, then for storage, and then from there it was pumped to your home. And just imagine all of these things happening at a city level. It becomes wasteful to use potable water where it is not needed. Water efficiency category in LEED rating system addresses the water by looking at indoor use, outdoor use, specialized uses, and metering. It recognizes non-potable water use and alternative water sources. So before moving ahead to strategies, we need to understand some basic concepts and terminologies that we will be referring to while discussing the strategies. The first thing is that what is a baseline case and what is a design case. In water efficiency category, a project earns credit by successfully cutting down on water usage compared to the predefined baseline. The points awarded to the project depend on how much the reduction exceeds from the baseline. So basically, in this category, when someone works on a project, they can earn points by using less water than what is considered normal or expected. Think of think of this normal amount of water as a starting point. If they use even less water than that, they will get more points for that. So the better they are at saving water, the more points they'll earn for their project in the water efficiency credit. The design case can be created from the baseline. Design case is basically the projected water use for our project. We design our systems in accordance to the design case. So let's recap. With the baseline, we understand how much water a typical building uses, and using a design case, we estimate how much water we want our building to use in the operations phase. So accordingly, we design our systems based on a design case, and we can see the overall reduction from the baseline in the design case. So the project is awarded points based on the amount of reduction done from the base case. Water measurement units of gallons per flush or gallons per minute are typically used to understand the base case and design case. Similarly, we can use liters per flush or liters per minute to also understand the base case and design case. I hope you understand the baseline and design case concepts. Moving ahead with the second important topic, which is the EPA of 1992. Daily water use is calculated using Energy Policy Act of 1992. The EP Act of 1992 sets the maximum flush and flow rates in building. Since we have to calculate daily water use, we would also need number of building occupants and their daily average fixture use. The EP Act specifies the baseline water consumption information required to make the calculation for projects' baseline water use. This table shows us the water consumption defined in EP Act of 1992. Like for a urinal, it is 1 gallon per flush or 3.8 liters per flush, and similarly defined for other things also, such as water closet, shower head. Now, the next very important concept is full-time equivalent. So, what is a full-time equivalent, or also called an FTE? It is a designation for a building occupant who spends more than 40 hours per week in the project building. You can also call them full time employees. That's how much an average full-time employee spends the time in the office per week. In a corporate office, an employee has 8 hours a day working for 5 days a week, which is roughly 40 hours a week. A occupant who is in building for 8 hours a day receives a FTE of 1, and similarly people working part-time and overtime get the FTE based on hours per week divided by 40. For example, I hire an intern who works 4 hours a day for 5 days. That means 20 hours a week, which would mean he would have an FTE of zero point 0.5. So, on an average, men and women go to toilet 3 times a day. It is assumed that men use urinal twice while WC once, but the women use WC 3 times a day. I hope you get the concepts around FTE and also called full-time equivalent. You should actually take down notes of these and pause the video here for the purpose of your LEED GA exam. Now let's begin with the main category of water efficiency. There are total 4 credits and 3 prerequisites in water efficiency. The maximum points achieved under this category are 11. Prerequisites are basically points that the project has to comply with to be qualified for LEED certification. As you can see, LEED category of water efficiency focuses on reducing the amount of potable water used for purpose other than drinking. Since the video is focused on strategies and intent, so we will not go credit by credit in this video. Rather, we will understand the broader concepts around this category, various intents and strategies to improve water efficiency in the project. Make sure to you understand the intent and strategies clearly. In any case, please leave a comment. And in this video, we will be only focusing on two things, which is intent and strategies for reducing indoor water use and for outdoor water use. So let's begin. The first we'll talk about intent and strategies for reducing indoor water use. The intent is fairly simple and straightforward. It basically is to reduce indoor water use by lessening the amount of potable water used inside the building. Again, potable water is basically water fit for drinking. The important thing here is that all the LEED projects must demonstrate reduction of indoor water use by 20% from the baseline case. Otherwise, the project cannot get a LEED certification. Once again, the baseline case is basically how much a typical building usually consumes water, and the LEED building in the very similar nature should consume 20% less water from the base case. Now let's understand what strategies a project can use to achieve this requirement or go even beyond it. So let's begin with the first strategy, which would be to install efficient fixtures. Installing high performance flush and low fixtures which have water sense labels help reduce water wastage of potable water and makes water fixtures more efficient. Now, what is a water sense? Water sense is an initiative by EPA to promote the use of partnership that brings water saving products and tips to the market. WaterSense products are 20% more water efficient than an average product in the same category. By just installing efficient water fixtures, your project can bring about a great impact when seen in culmination over a span of building life. For example, instead of using 100 liters a day, if you can do the same activity in 80 liters a day, by the end of the year, you would have saved 7,000 liters of potable water. Isn't that something great? So now let's begin with various strategies in efficient fixtures that will help you make a better decision while choosing a fixture. The first one is ultra low flow closets. It is a type of closet that includes a pressure tank to produce a pressure assisted flush. It usually requires higher maintenance than a regular water closet, so it is preferred in commercial buildings or industrial setting, and it is not preferred in a residential areas where everyday maintenance can become very expensive. The second type of technology for efficient fixture is dual flush water closet. This is one of the most common type of WC you will find. It provides you with two options for flushing, one for flushing liquid waste which roughly uses zero point 0.8 to 1 gallon per flush, and the other to remove the solid waste which typically requires 1.28 to 1.6 gallons per flush. By choosing the appropriate flush options, a person can significantly reduce the amount of water used without reducing the effectiveness of the flushing action. The third option is to install an ultra low flow urinal. The urinal uses optimized valve that produces a pressure assisted flush that produces less water than the regular urinal. Roughly, ultra low flow urinals use about 0.125 gallons per flush. You need not remember these numbers for the purpose of your exam, but it is important to understand the technologies which are present in the market. And the fourth option is to install low flow aerators. Usually, replacing the complete fixture can be very expensive. So instead, we can just install a low flow aerator on the head of the fixture. It basically mixes air with the water so that the overall water flowing is reduced and the person using the fixture gets the same feeling of having a handful of water falling out from the fixture. You must have experienced such fixtures in malls and or airports. This can reduce up to 50% of water flowing from the fixture, which is like really good enough. And you can pause the video here and take the note of these things for the purpose of your LEED GA exam. Now, moving on to the second strategy is to reduce indoor water use, which would be to use waterless fixtures. Now, you might be wondering what are waterless fixtures? Waterless fixtures are touch-free fixtures that are designed to be entirely water-free. Instead of using water to clean the bowl, urine travels down specially coated bowls through specially designed cartridges that ensure fixtures remain odor-free. The water fixtures can save considerable amount of water, but may require more maintenance than a regular fixture. So the first type of waterless fixture is a waterless urinal. It is a urinal designed to allow urine to flow through a trapped device without using water. Urinals usually take a lot of water every time we flush. So commercially, it becomes a lot of sense to install them on a commercial level, such as malls or airports. And they usually take more maintenance than the urinals using water. So in long run, especially in public and commercial spaces, they can help you save tremendous amount of water. A liquid sealant floats over the urine that traps the foul smelling gas. So next time when you visit an airport or a stadium, you might get to notice these kind of urinals. Moving on to the next fixture, which is a composting toilet. In this, the collected solid waste is converted into organic matter without using water. Aerobic microorganisms break the waste using available water and oxygen, reducing the volume down to 1 to 2% of its original volume. Such technology is preferred in campuses that are not connected to municipal solid waste lines or that promotes decentralized systems. And you can pause the video here and take down the strategies. The third strategy would be to using water reclamation systems. Let's understand what is this first. Water reclamation basically means making use of water that was intended to go down the drain or storm sewer. It can be said reusing the water after processing it. Once the water is reclaimed, it can be used in place of potable water in various applications. Depending upon the use, the reclaimed water may or may not require treatment. Now let's understand some techniques of water reclamation system. The most common system is rainwater harvesting system. It is a process of collecting water from rooftops and paved areas for reuse. Rainwater harvesting systems have been used since ages, especially in arid areas. In India, especially in Rajasthan, you can see very beautifully designed rainwater harvesting systems that store water throughout the year. Rainwater directly cannot be used for drinking, however, it can be used for irrigation and non-potable use activities. You can also drink rainwater after a proper treatment. Moving on to the second system, which is the use of grey water. No, the water is not grey in color. Let's understand what is grey water first. It is the untreated household wastewater that has not come into contact with the toilet waste. It can include water from washing machine, water tubs, bathroom sinks, and it does not include water from kitchen sink or dishwasher. Grey water can be stored for non-potable uses such as irrigation. Filtered grey water can even be used for more purposes such as flushing or and mopping. The third type of system is to use reclaimed water. Reclaimed water is commonly effluent from a wastewater treatment plant that has undergone treatment to remove harmful pathogen, organic material, and heavy metals. The use of reclaimed water depends on the level of treatment of water. It can be used for residential and commercial landscaping, irrigation, dust control, industrial use, toilet and urinal flushing, or process application, vehicle washing. That's pretty much about the water reclamation system, and you can take a note of them. And please don't forget to hit the subscribe button. It'll really help us grow and reach wider audience. Moving ahead, the fourth strategy is to install sub-meters. It's like wearing an Apple Watch. It can't do exercise for you, but it can tell you how inactive your lifestyle is. Similarly, sub-metering tells us how much water we are using and where. It is mandatory for all the lead projects to permanently install sub-meters to measure total amount of potable water that is being used. Sub-metering at micro level, let's say kitchen, toilets, help us to catch leaks in water pipes easily. Just by installing sub-meters, building can reduce water consumption by 30 to 40% in first few months. LEED gives you credit for installing sub-meter on two or more of the following, which are irrigation system, indoor plumbing fixture, domestic hot water systems, boiler, reclaimed water. The last strategy to reduce indoor water use would be to reduce processed water. Processed water is all of the building's water that is used for industrial purposes in building systems such as cooling tower. Instead of using fresh potable water for cooling towers, we can use treated rainwater or reclaimed water for it. This would overall reduce the potable water requirement substantially. Usually, when we try to optimize anything that is linked to operations, we tend to do substantial amount of savings. Please pause the video here and take the note of this for your purpose of elite GA exam. Now moving on to the second topic, which is reducing outdoor water use. We first talk about reducing indoor requirement. Now we move to the outside. Primarily, outdoor water deals with irrigation and landscape use. Sprinklers and drip irrigation are the two most popular ways to irrigate with water efficiently. No, no, Now let's understand the intent of reducing outdoor water use. So the intent is to reduce the amount of water required for building site irrigation. This shall help us to reduce a site that requires little, if no, irrigation. Now let's understand the strategies that will help us achieve this intent. The strategies address the type of landscape on a project and the water sources that can be used to reduce potable water for irrigation, similar to what we studied in the last topic, reducing indoor water use. So the first strategy would be to choose native and locally adaptive species. So when we are planting trees or shrubs, it is always better to put species that are native of that place because they're already accustomed to the local temperatures, humidity, annual rainfall, and they are most likely to be survive naturally after a given certain time. It is like when you travel to a foreign country, you don't understand language, food is different, people are different, you are most likely not accustomed to the weather, so which makes that you would not be comfortable in that setting for long. It is similar for trees and plants. Native plants help reduce irrigation requirement because they are already adapted to the climate of the site. The second strategy would be to do xeriscaping. So now what is the xeriscaping? Xeriscaping is a type of landscaping design that utilizes soil improvements, efficient irrigation, and native as well as adapted plant species to reduce water use. They are primarily thorny species that are found in arid areas, so they do not demand any water and usually survive on annual rainfall. The third strategy is to select and install efficient irrigation technology. One of the most common technology is drip irrigation. It delivers water directly to the roots of the plant, which eliminates water losses due to evaporation or runoff. It is expensive to install initially as all the work needs to be done before, but it becomes very difficult to install drip irrigation after the plants have been placed. The fourth strategy, once again, would be to harvest rainwater. Capturing and collecting rainwater is the first step in using non-potable water for irrigation. We usually use cisterns for collecting the rainwater on a commercial level, and similarly can be done on a residential level. The next strategy would be to use non-potable water for irrigation. Just like we have been discussing in this video, there are various sources of non-potable water such as rainwater or reclaimed water. One should try to use this water for purpose of irrigation after making sure the water is of suitable quality. If the water is not of suitable, if the water is not suitable for irrigation, it is recommended to treat the water. The reclaimed water is usually denoted with a purple pipe. I hope you remember what is reclaimed water. If not, please rewind the video and for to indoor water use reduction. The last but not least strategy would be to install sub-meters. Metering outdoor water use is important to reduce the outdoor water use. Once you know how much water on an average you are consuming, you can take measures accordingly to reduce it. And if someday you see that the consumption has been higher than required, you can know that something is wrong and appropriate measures to fix it can be taken. Now you can pause the video here and take the note of these concepts, and I hope you understand them too. Please hit the subscribe button, like it'll really help us grow. Now let's do a quick question. What standard are used by LEED in water efficiency to determine the base case for the building? EPA Energy Star, BREEAM, ISO, EPA Act of 1992, or ASHRAE 90.1? I've repeated multiple times this in this video that this is an important concept, and I hope you remember. And the correct answer is EPA Act of 1992, Energy Policy Act of 1992. I hope you remember this because this is most likely to be tested in your exam. Please do check out the question bank for more such practice question, and the link is in description. That's pretty much for water efficiency intent and strategies. Please hit the subscribe button and like also, and share it with your friends who are preparing for LEED GA exam. And see you in the next video. Thank you.